dairy wastewater treatment process has several stages. In the early stages, influent wastewater will go through a screening process that is the separation of light insoluble material from wastewater flow. For municipal and industrial applications, this screen can also be utilized for product recovery, big solid separation, and mixed settleable solids. After that, wastewater will be channeled to the equalization tank for the process to equalize and reduce any differences in water parameters such as flow rates and organic mass. If a plant is expecting to receive a large amount of septage or is bringing in a large amount of industrial waste, flow equalization is also important. After that, the wastewater will be put into the aeration tank. This process is intended to allow a rapid biodegradation of the organic materials by adding air into the wastewater to provide oxygen to bacteria for treating and stabilizing the wastewater. Next, the feed will be put into a settling tank for the process of separating sludge from wastewater. This process allows suspended particles to settle out of water or wastewater as it flows slowly through the tank before being sent to the next process. The accumulated excess sludge will be transferred to the aerobic digestion tank. The excess sludge will be aerated for a few days, will be dioxidized, and there will be a reduction in volume subsequently returned to the aeration tank. Last but not least, wastewater that has been separated with sludge will be put into the chlorination tank. This process is to sterilize or disinfect the water from harmful pathogens by using chlorine before being released into the environment or reused.
The sequencing batch reactor (SBR) is a fill and draw activated sludge system for wastewater treatment. In this system, wastewater is added to a single batch reactor treated to remove undesirable components and then discharged. Sequencing batch reactors (SBR) or sequential batch reactors are industrial processing tanks for the treatment of wastewater. It treats wastewater such as sewage or output from anaerobic digesters or mechanical biological treatment facilities in batches. To optimize the performance of the system, 2 or more batch reactors are used in the predetermined sequence of operation. SBR systems have been successfully used to treat both municipal and industrial wastewater. They are uniquely suited for wastewater treatment application characterized by low or intermittent flow condition.
Next, we're gonna talk about the schematic diagram of the sequential batch reactor. On our left is the diagram of the sequential batch reactor. Based on the schematic diagram of the reactor, there are a total of 15 components that were in the reactor. The components are, first, the reactor, the control system, the effluent tank, the effluent tank, the sludge tank, the aerators, the circulating pump, the sampler, ORP meter, DO meter, pH meter, heater, solenoid valve, peristaltic pump, and lastly, the A stone.
Hi everyone, so I will present next item, which is item 4, component in sequential batch reactor and its function. Firstly, reactor. In this system, wastewater is added to a single batch reactor that treated to remove undesirable components and then discharged. Next, control system. There is 2 controllers, which are solenoid valve and pH meter. Solenoid valve function as a pump. In wastewater production, if there is no prone solenoid valve, then there is no pump. Next slide is, there is pump in this system, which is peristaltic pump. This component was used to add influent and remove effluent. Waste activated sludge was also removed at the end of the aerobic phase once every 24 hours. The ion selective electrodes were all located at the reactor. These parameters is important in nitrification kinetics. The optimum temperature is between 25 and 35 degrees Celsius, whereas the rate of nitrification drops to 50% of the optimum if the pH lies beyond the range of 7.5 to 9.8. The ORP meter is providing an indication of ability of a solution to oxidize or reduce another solution. Lastly, the tank. During the fill phase, the tank receives the raw wastewater that comes in contact with the active biomass left inside the tank at the end of the previous cycle. In addition, the control system in SBR is complex than a conventional activated sludge system and includes automatic switch, automatic valve, and instrumentation. Next, I will pass this to my partner for present the next item. That's all from me. Thank you.
Lastly, we're gonna discuss about the advantages and disadvantages of our reactor. There are several advantages of sequential batch reactor or SBR. First, the reactor is high treatment efficiency, possible for BOD, COD, TSS, and also P. Second, it also has high flexibility in operating conditions. SBR also has possibility of producing electric energy from biogas. And finally, SBR use less land requirement than CAS due to the compact tank construction. For the disadvantages of SBR, it has low pathogen removal. SBR also requires skilled personnel, particularly for SBR with sludge digestion. It is also dependent on an uninterrupted power supply. SBR also requires more automation than CAS or EA. It also needs high maintenance requirements. SBR also depended on some foreign spare parts that were almost inevitable. This reactor also high on capex and opex, but cheaper than CAS or EA.